Hello everyone. Today's video is about a company called PQShield that is working on post-quantum cryptography, and if you are similarly interested than I am in this specific topic and you want to learn how we can protect ourselves against the threat of quantum computers in the future, then today's video is probably the right one for you. Then please get yourself something to drink so you stay hydrated throughout the video, and let's get started. So the company is called PQShield, and if I had to guess, and I will just do it because you cannot tell me not to, this would be probably for post-quantum shields, so shielding us from the threats that are in the post-quantum era waiting for us. So after a quantum computer is there that is powerful enough to crack today's encryption. So here on the website it says think openly, build securely, so real-world post-quantum hardware and software upgrades, modernizing the vital security systems and components of the world's technology supply chain. We see a couple of headlines in this little carousel going through here. Featured product is the PQ Microlib Core, very intuitive name. And then also another featured product here is the PQ Perform Inferon, also very intuitive name. We will learn about these later on. Then we see the partners here and recognition. So you see companies like Capgemini, Deutsche Telekom, and then if you scroll through AWS, Kudelski I think is also in here, Kudelski Security, Intralink, Bosch, so various different companies down here that are part of the partner network, also the World Economic Forum, and many, many more. I'm not going to go through all of these now. Then it says, we know the problem. So always good if you know which problem you're working on. We are helping to shape the way our digital world is protected against the threats of tomorrow. At a time when quantum computers will soon be able to break current cryptographic methods, PQShield is focused on empowering organizations, industries, and nations with the ultimate quantum-resistant hardware and software solutions. Then we set the standards. So Team PQShield promises a world-class collaboration of post-quantum cryptographers, researchers, and engineers. We've been actively involved in the international standardization of post-quantum algorithms, and we were the first cybersecurity company to develop quantum-safe cryptography on chips, in applications, and in the cloud. We know the priority markets. So here you see automotive, industrial, system integrators, and I'm not going to go through all of these because they are also linked in the upper navigation bar, so we will see them later on. And we help our customers. So collectively, we spent decades developing the research that leads to world-class PQC solutions for the technology supply chain, and then discuss, evaluate, design, and implement is the cycle that you go through when you actually build, let's say, full-on solutions with the components that PQShield is providing. Finally, down here we see we have mature PQC security suite to feed the supply chain. So you see the different products in here with the different names, and we will go through them in a second. We publish our work, so our team of world-class experts are committed to empowering organizations with the latest developments in post-quantum cryptography. Check out Team PQShield's latest PQC and security insights, and then we drive the conversation, read the latest news, findings, and insights, and so on. And we will check some of that out later because I think there's some truly cool stuff hidden here on this website. So very insightful, like very, let's say, niche specific. But if you want to know in which direction things are going, I think this is an interesting website to follow. And I will show you later on in this video why I think so. Then finally down here, we see the upcoming events. So I'm recording this in March 2026. And you see here is the Securing the Future Anywhere PQShield at RSAC 2026, link down here for San Francisco, USA. But you can also see they are active around the globe. Finally, there's some link to the newsletter and then the usual stuff down here with all the additional links and stuff that you might need or might not need. Now, let's go all the way up again and take a look into this section with all the information here. So first of all is the products. And here I already told you the naming, of course it follows a logic, but we got to figure out now together what these different components actually are and how they play together. So Ultra PQShield, Mature PQC in software, FPGA and ASIC. So FPGA is a field programmable gate array that is a piece or a chip that you can actually program to do a specific function, to perform a specific functionality. So it is not the same as a CPU that has a specific underlying architecture that is then being used to perform specific like general tasks, but it is a chip where you can program the underlying architecture. So you can program it to do something very specific. And an ASIC is then basically the next step. So once you have, for example, developed something with an FPGA, you might actually figure out, okay, this is a mass application, so it makes sense to form that into an ASIC. So then basically you take this architecture that you've built and you kind of create a lithography pattern or create an actual chip from that has exactly this specific task, and that's usually what then this ASIC process is referring to. So you see, it starts at the software at the high level, then it goes via FPGA all the way down to ASIC, so to the chip design. An unparalleled range of IP for many use cases in your PQC migration from the people who help write the standards. So very deep expertise and knowledge, a lot of authority shown basically by this. So if you have somebody who is writing the standards, that means they are like really considered the experts in the field. And I mean, the IP, of course, then stretches from the ASIC all the way up into the software and application layer, which is basically the whole span, right? So it's a one-stop shop more or less for post-quantum security. So, but now let's look at the products. So we see also reflected here in this family the different layers. So embedded software IP, system level software IP, platform security, hardware IP, and then on the lowest level, the performance hardware IP. And let's start maybe from the bottom and then go all the way up to the top. So there is first of all the PQ Performance Flex. So Inferon plus RISC-V processor for enhanced crypto agility. RISC-V is an open standard, so an open command set, more or less, or it's an open standard to build your own types of processors. It is basically the open analogon to an x86, which or like an ARM type of architecture. Then you see here the platform in Inferon, so highly configurable hardware, I guess, lattice PQC, ultra acceleration in AXI4 and PCIe based systems from core only to multi-instance manager with queuing or streaming. So that's already quite, let's say, deep down into the world of compute. So PQC ultra acceleration, so it is an accelerator chip or an accelerator card, whatever you want to call it. I don't think it's defined here. And it comes with a PCIe based connection. So PCIe is how you basically link those systems to your CPU, to your host system, from core only to multi-instance manager with queuing or streaming. Then on top of that, we have the Perform Flare, so single instance HW lattice PQC ultra accelerator as an AXI subordinate. Now we come to and I'm not going to comment on every single one of them, right? Obviously. First of all, because I don't know everything, and secondly, because otherwise we are still here tomorrow. So platform security, hardware IP. So that's where the platform truths comes in. Highly configurable, autonomous HW PQC acceleration with RISC-V processor for full CPU offload, configurable as a subsystem or full root of trust with SCA and FIA. So I guess that's then the next level of hardware acceleration engine. Then highly configurable, the platform CoPro, highly configurable hardware PQC acceleration for existing subsystems from hash only to PQT hybrid with SCA and FIA. And then finally the platform AES is an AES accelerator with SCA. On top, we have the software level where it says CryptoLib SDK, so software development kit, right? Core plus OpenSSL 3x provider for ease of integration. Then we have the CryptoLib core, highly configurable FIPS 140-3 software PQC library for classical PQC and PQT hybrid on Linux, Windows, and Mac OS. So runs on all the major operating systems. And then we see the MicroLib core, so optimizable bare metal PQC library with 13 kilobyte RAM with option to include DPA protection. So different layers, different functionalities, but basically a full solution going from the ASIC all the way up to the application layer that sits within your operating system that runs on your computer. Then we also see here competitors, open source, and in-house teams, and you see the different PQ microlib platform and the perform part. So where we truly excel is the PQC that is ultra fast, ultra small, or ultra secure. So that's the three angles that we see here, right? So like the extremes, implementation matters. In fact, fundamentally changing the cryptography behind the scenes mean the way in which it's implemented is becoming increasingly important. It's even more acute at the extremes of optimizing for fast performance, high security, or low footprint. PQShield's deep knowledge, along with our partners, protocols, and security techniques, enables us to move way beyond the competition and open source. We can deliver high quality products to address these optimization problems head-on, allowing you as a vendor to reduce time to market and helping you to build PQC into greenfield and brownfield products. So I think that is important to mention. So the typical target audience for them is probably, let's say, in the very professional level. So this is probably not so much the tinkerers, maybe also not the startups that just start to build products and include this post-quantum cryptography mechanisms into those products. Maybe also not for labs to tinker around, but really like for the high performance, for the highly demanding and super optimized cases. Like if you, for example, have a mass product, everything needs to be super optimized. It needs to be super cost efficient. If you have, let's say, high performance compute, every single compute bit that you can squeeze out counts. So I guess in all of these applications where you really need to, let's say, tailor the solution also a little bit towards the application demands, I think that's, from my understanding, what I see here, where PQShield would then come in. Again, here we have the different products, and I'm not going to go through each single one of them now. And then down here, we see the multi-level security profiles that I think were mentioned also previously. So it goes basically from the cloud, edge devices, lab, and then finally you have the government level where you probably have the highest demand for security. And it's also basically explained here with the different levels, I think. Finally, there's a get in touch section down here. I'm not going to go into all of these products. I just want to show you maybe the first one, which is the PQ microlib core. So highly optimizable bare metal PQC library in as little as 5 kilobyte RAM with option to include DPA protection. So microlib PQ microlib core is a CAVP ready version of PQShield's CMVP certified PQ cryptolib core, tailored specifically to embedded systems running bare metal or with real-time operating systems. So that's usually what you require into production machines, any types of robots that have to act on real time. And then of course we also see here if you need this small footprint in embedded devices, because usually they don't have an infinite amount of compute power and also not an infinite amount of energy budget to run on. So that's where this specific, and that's probably the micro in here, right? It might even be able to run on a microcontroller, I don't know, could be coming in. So this is in this ultra small or close to ultra small section down here. It also lists the key benefits, but I think I'm not going to go into the details because first of all, I'm not an expert. And then secondly, I also don't want to, I want to spare you a bit the details. Now, which markets are they actually catering to? What are the interesting markets for this PQ post-quantum kind of cryptography as of today? So, markets. Understanding the problem. Quantum computing will soon have the power to break traditional cryptographic methods. That's something that we've talked about also in previous episodes of this Hidden Champions video playlist. If you haven't seen them, check out the playlist on the YouTube channel. But this topic is becoming more and more discussed. And at some point, there might be a quantum computer that can, using a version of the Shor algorithm, break those classical encryption techniques which rely on prime factorization as of today, and then basically the information might be exposed. And there are certain places where this is maybe less critical, but there are other ones where this is critical over a long period of time, also referring to the harvest now, decrypt later idea. For example, your medical data, which even in 20 years from now, you might not want to have it exposed somewhere. So back to the text, that's because quantum computers are exponentially efficient at solving mathematical problems, and it's those problems that current cryptography relies on when it comes to encrypting our digital information. By the way, a quick note, so all of this is very heuristic, the whole cryptography, right? So there is no algorithm to figure out these prime numbers, and that's the premise on which the whole cryptography is built. If tomorrow somebody wakes up and comes up with an idea of how to easily extract prime numbers from a big number that you give them, you don't even need a quantum computer. You can basically just break the whole encryption with this algorithm that somebody came up with. But as of today, we don't know any algorithm, and to my knowledge, there is no mathematical proof that shows that it doesn't exist. It's just like we don't know any algorithm. There's nobody who ever figured out one that can extract these prime numbers easily, and that's basically what our whole encryption relies on. You say it takes X amount for a big computer or for the biggest computer in the world to figure out this prime number, and then you just take one which is big enough that it takes a computer for such a long time that it practically never happens. So you say, for example, the universe is X number of years old, and if it takes a computer longer than the universe, than the age of the universe, that's probably not going to break anything. And that's how our encryption is more or less built. That's how we make sure that our private data stays private. And that's where we don't know classically an algorithm that can break it, but with a quantum computer, there is one that can do it faster. And that's why this quantum thread is there, right? Back to the text. So this new technology means that in every single industry, the cryptography that keeps data, devices, connections, and components secure needs to be modernized in order to align with new post-quantum global standards. This modernization is already underway. Below are just a few of the markets that are focusing on migration as a priority. And to say that also, there will probably be more and more regulation on this topic, there is already, or there have already been first studies that have been commissioned on like how to, or what are the standards that are considered to be post-quantum secure, right? This is also where, for example, the experts from PQShield have contributed, right? And following from that, there will probably be some regulation. Now, back to the companies. So we see semiconductor and manufacturing. Semiconductors are a fundamental component of modern electronics and are essential to the production of hardware in complex global supply chains. Ensuring the security and integrity of data and devices in these supply chains is vital, and PQC is essential when it comes to protecting the sensitive information required for semiconductor design, distribution, and manufacturing. Then we see military and aerospace or defense, right? Quantum resistance is essential for the protection of critical national infrastructure and defense. PQC solutions can help upgrade hardware and software to become resilient against quantum attack. Classified data held by defense and aerospace organizations can have a long shelf life and even now is at risk of interception and future decryption. Then we have identity and payment, so finance, right? With the development of online financial transactions, integrity and security are essential to the way the world does business. In the next few years, the technology that keeps organizations and financial data safe online will be under threat from quantum attack on legacy systems, with financial institutions particularly at risk from target attack. Modernization to PQC is essential. System integrators, so manufactured products, often require components and assets that are integrated from the technology supply chain. System integrators need confidence that components are built on a secure platform and that the process to design, build, and deployment of those integrated products is safe from malicious attackers. Then we have the automotive sector. With advances in technology, the production of vehicles now involves processes and components that rely on data security and integrity of communications. In addition, vehicles use components that may have a long shelf life, meaning that in the decades to come, today's technology will still be on the road. Migration to PQC must become a priority for the automotive industry. And I think this is not only for automotive, this is probably applying to the whole transportation. So also aerospace, also railway, the whole transportation sector relies on these long life cycle products because they are incredibly complex products, and you cannot just, like in a consumer product, design a new product every single year and change your whole production line, right? So it makes sense that they have these long production cycles, but then of course it also has some implications, like here talking about the safety and the security of the data. And I think this, for example, applies to over-the-air updates in your car, right? You want to make sure that this is encrypted in a proper way, that nobody can sneak in between and, I don't know, hack your car because they can sniff in between the software and whatnot, right? Okay, industrial IoT, automated systems, monitoring equipment, environmental controls, and interconnected devices often rely on certain security protocols to communicate, and as such are perpetually at risk of interception by malicious actors. With the advent of quantum computing, it is possible that many of these IoT systems could become entry points to an organization's network of operation. So think about your smart fridge, think about your smart dishwasher at home, right? They have internet connection because of some funny feature that some manufacturer came up with. Now think about a corporate environment where you have many of these devices, actually an uncontrollable amount of those devices. And if even a single one of them has some firmware issue, and they will have at some point because maybe one of those companies goes bankrupt and they don't really further develop their firmware anymore, they don't invest into that anymore, somebody can hack into that. And from this entry point, and it sounds very stupid, but this is how it works, right? From this entry point, from your smart clock that you have hanging somewhere, or your smart temperature sensor that you have hanging somewhere, they can actually enter into your whole network at home because it's connected, and then hack into all other devices. So that's where these become entry points, and that's why it's also good practice to have an IoT network that is separated from the network where like the actual assets are. But of course, there's also other measures to be taken, like for example, this post-quantum cryptography. Then we see, of course, network and telecommunications here. In an increasingly connected world, it's important to be able to continue to protect the world's communications and data networks from malicious interception or attack from the latest threats. Migrating to PQC requires updating existing network infrastructure, protocols, software, and authentication methods, identity management mechanisms, and user provisioning. And then finally, there's healthcare. I mentioned this before with your health data, right? So healthcare is becoming increasingly digital and interconnected, with sensitive data flowing continuously between medical devices, hospital systems, cloud services, and patients. From wearable monitors and imaging equipment to electronic health records and telemedicine platforms, these systems rely on the confidentiality, integrity, and availability of data to deliver safe and efficient care. One thing that all of these have in common is whenever you are designing or whenever you are spending something into making products more secure, it doesn't come with new features. So it's usually not the first thing that people look into, because you technically don't benefit, or you technically don't create on the first side a user benefit that is visual to the outside, right? It's not like you're coming with this new cool feature which makes people buy this tool. But on the opposite side, like the downlift is very big. If you don't invest into it and somebody hacks into your system and everyone knows, okay, these systems, they're not safe because they don't invest into making safe systems, then it can be a substantial risk. It can be a threat for a whole company, right? So it's always this kind of ambiguity that making systems secure brings with it, or that could end up in a pitfall. Now, let's quickly, after seeing the markets, not go into the publication, also not the news, but into the industry insights, because here I think there's some quite interesting value hidden in there. I was mentioning that before, and I think really for me this is kind of an eye-opening side, and probably some side that I will also come back to at some point in time. So, industry insights. The cryptography landscape is evolving fast, from global standardization effort to new regulatory and implementation challenges. PQShield's industry insights bring together expert analysis, guidance, and commentary on the latest developments shaping the future of post-quantum security. This is where industry leaders can come to understand what's next, why it matters, and how to prepare for a quantum secure world. Below is a graphical summary of the PQC window for PQC deployment, and read on to learn more about the specific guidance by geography. So what do we see here? So we see a timeline starting from 2023 and before, all the way to 2035. Now it starts with this little blue window here, which is called the NIST timeline. Then it goes into the NIST standards published in 2020. I think this is the whole NIST pipeline. And then it says NIST standards published in 2024. So that was 2 years ago. Then comes this era here from 2024 to 2030 until it says RSA and ECC algorithms deprecated. So from that point of view, they are considered old. And then in 2035, it actually even says RSA and ECC algorithms disallowed. So from 2035, which is less than 10 years from now, these algorithms are not anymore allowed to be used for encryption. Now, who does it count for? So who's affected by that? And that's what you can see down here. So it ends with the full migration, right? And it starts with the critical infrastructure. So we are today in 2026, and we see that basically all of these players have committed onto something now. We see, for example, here the EU, but we also see countries within the EU like France and Germany and the Netherlands who already started a little bit earlier. We also see other developed countries like Japan, South Korea that are on this track here. And since 2026, for example, also India is joining for this. There's also China, Canada, and you also see the US, of course, here as well, starting with the NSA and then US federal agencies as well. Now, looking at this timeline, you see that a couple of those players, they have committed already on this intermediate step here of critical infrastructure. So this is this 2030 where we say, okay, RSA and ECC are now deprecated for critical infrastructure applications. And then in 2035, for most of these players here, it will be stopped. For some, like the NSA, and for example for India, it's already 2033 where they basically deprecate today's current standard for cryptography. Down below here, and I think that's also super interesting, there are many resources linked as well. They are sorted by geography. You get a comment from PQShield themselves as well as the sources. And again, I'm recording this in March, so it's very much up to date. You can see March 2026, Cyber Strategy for America, President Trump's Cyber Strategy for America. And there's also some blog article here, President Trump's 2026 Cyber Strategy, what it means for quantum readiness. And you can see they are not just focused on the Western world, not just on the US or the EU, but it's really like a global view on this topic. You see, for example, here India, you see Hong Kong, the United Emirates. So it's really like widely spread across the globe. There are also some global news, and you can also see it's pretty detailed. So it's not just like they are doing 1 or 2 articles per year, but it looks like almost every month there's an update here. You see 2025, 2024. So it goes all the way down to basically 2022 with the European Commission that is being linked down here. And then, yeah, we see there are many articles in here. So I think probably a very valuable resource. And if you are active in the sector, or if you are, let's say, monitoring the status of post-quantum, or if you want to know how the timelines have changed and how active development, like new algorithm development, new breakthroughs in the quantum computing research affects those timelines that are being set here, this is probably one of those resources that I would check out. Of course, amongst others, right? But from my point of view, definitely very valuable to have this here. Now, as per usual, at the end of every video, first of all, I'm very happy that you stayed all the way until here. So thank you very much for staying on with me. I know it's a long video, and if you are still here, please give the video a thumbs up so I know that you actually watched all the way to this point. I want to quickly also take a look at the company. So who are the people behind the company? How does the company identify itself? So Team PQShield. PQShield comprises a world-class collaboration of post-quantum cryptographers, engineers, and researchers. We've helped shape all of the first international PQC NIST standards, and we were the first cybersecurity company to develop post-quantum safe cryptography on chips, in applications, and in the cloud. And here we see the whole team, and that really shows like this is a proper company, and it's not just 5 engineers sitting in a garage building something. Anyways, if you are able to tape out a chip, it means there's a substantial investment going into that. So here's really, let's say, a big business necessary to build something like this. And yeah, here we see it starts with the founder and CEO, Dr. Ali El-Kafarani. I'm probably mispronouncing that. Sorry for that. And the leadership board all the way towards the advisors. But you also see the engineers. You see financial director, so all the functionalities that a proper company has. And actually it's a quite big company. I see also different names from different probably countries or different cultures, so it's very international as well. And then of course down here, as per usual, the CTA, the call to action to take a look at the careers page and for the newsletter. With that, I think we are at the end of today's video about PQShield. I hope you liked it. If so, make sure to subscribe to this channel to not miss out on the next one. As always, make sure to stay hydrated and see you in the next video. Until then, bye bye.